Okay, so we're question 9 of 2015, paper 1, section B. So this one is worth 30 marks and won't be too long. Now you see here a scenario where this girl Amanda is buying a car. Actually, I would stop here a second and say you should pause this and have a go at it. We already have had a go at it prior to this. But I suspect a new car, you buy it off the lot, drive it off the lot, it depreciates in value. Okay. So she knows that the value of cars depreciates by a fixed percentage every year. She draws the graph below to represent the value of her car for the next 6 years. So you're given this graph. You just have to interpret the graph. You've kind of done this already in this exam, 2015, paper 1. So you use Amanda's graph to estimate the length of time it would take for the car to depreciate from 15,000 to 10,000. So from 15,000, where it cuts the graph, drop it down. That's roughly there. To approximately 10,000. Bring that line across where it hits the curve. Drop it down. That's a difference of 1 full year and 3/4. So 1 3/4 years. Okay. So now, in whatever way I've read this off, 4 take away 2.2. Okay, it's a little bit over now. It could be my graph here itself is kind of off. I'm making it up. Whatever you've indicated on your graph, if you take those two numbers away, you're gonna be cool. Okay. So the next, go back for a second. Continue Amanda's graph to find the approximate value of the car after 7.5 years. So if that curve continues, kind of going in that direction and leveling out. So 7.5 years is 7 and it's 2 boxes half. Bring it up to where the line touches here. Bring it across. Now obviously that's I'm trying to straighten up that line. You'll be using a ruler and pencil. This is a hit and miss. If you're not right, you're wrong. Okay, you get no marks. But again, it'll be based on your work. So we're saying they're approximately that's 7.5. I'm saying 4,500 there. Okay. Looks okay as an answer. The last one then, what name is given to the type of curve Amanda has drawn above? I can see if somebody would say quadratic. My first look at it I was like, oh, that's quadratic. But actually it's exponential, so it's going up and it's going up faster and faster and faster. Okay, and that'll be exponential. That's part A, part 1, 2, and 3 done. Okay, so part B now. On the day that Amanda bought her car, Cathal also bought a new car. His car cost 22,500. Now this will be tricky. Amanda's car will travel 15 kilometers on a litre of fuel. So I'd write that out. 15k equals 1 litre. Just to try to get the attempt, even if you get stuck. Cathal's car will travel 10k. Okay, on 1 litre. Now, obviously, Amanda's car is more fuel efficient. She's going a further distance on her fuel, so that's a better choice, depending on how much you drive. Now, how many kilometers will the cars have to travel until the price of the car plus the cost of the fuel are equal for the two cars? Assume that fuel costs 1.5 per litre over the period. So technically there's two linear, if I'm right here, there'll be two linear equations going. So that might be like Amanda's thing, and that might be Cathal's. He started at a lower price, okay, but eventually he's going to overtake her, okay, in terms of cost, because he's paying more for fuel every time he drives. And they're looking for how many kilometers that would be. So you have to set up two linear equations, okay, and what's the answer here? If you think about Amanda's car, the cost of her car equals 25,000 plus 0.1 for every kilometre driven. Okay. Now you got that by dividing the 1.5, okay, by 15. So that represents 10 cents for every kilometre. Okay, 1.5 euro divided by 15. Then the same thing with Cathal. Now here's 1.5 euro for every 10 kilometres. So he's paying 15 cents per kilometre. So K represents the number of kilometres driven. Okay, so if you put in 1,000, it's going to cost her whatever. So 1,000 is going to cost Cathal whatever. Now, as I said, they're both linear equations. If you had the graph, you could read it off. But one classic thing to do with two linear equations is solve them using simultaneous equations, and the answer is the point of intersection of both lines. So it's classic, question in algebra. I'm putting the two things equal to each other. Okay. I'm going to solve then for k, so I bring the 0.1k across the equal, change it to a minus going across. So then I end up at 0.15, take away 0.1, I'm left with 0.05. Now if you're not sure of decimal, just use the calculator for that. I bring my 22,500 across the equal to the left hand side. Was plus on the right, goes to become minus on the left. Take those two figures away and I get 2,500. And to solve it, okay, I want to move this 0.05 away from k. It's multiplied on the right, goes across to the far side, becomes divided. End up here. That's the sum. Put it in the calculator and it's 50,000 kilometers. So after 50,000 kilometers, Amanda's paid less than Colin, even though Colin's car cost less than initially due to the fuel efficiency. Okay, so that's that. Now, it's at the end of question 9, okay? 5, 15. Okay, I'm missing something. 15 and 5 is 20, not 30. Okay, so I'll just pause this and we'll see if I missed something. Okay, I just realized that it's 15 and the 5 and the 5 gives me 25, and then the 5 marks for this part here gives me the rest, okay? So, I just got confused reading this. Okay, I'm sorry about that, waste your time. That's question 9, the last question on page 2015, paper 1. Again, if you have any questions, you can contact me and we'll sort through them, okay? So, appreciate it, thank you.